M4, Simplify Radical Expressions with Variables, Part 1. I've given you some criteria right here. Before we begin, every question is going to say, write your answer in the form of A, or the square root of B, or A squared of B, or A and B are constants or expressions in X. Use at most one radical in your answer and at most one absolute value symbol in your expression for A. So that's just telling you how to write your answer. Every time we do this, we're going to do the same exact thing. Now, on this criteria, this line right here means it has an exponent. It has a power, but I don't know what the power is. It doesn't really matter. But once you have this power and it's an even root and you get an even answer, then your answer is just your answer. But if you have this exponent and you have an even root and you get an odd exponent answer, that's when you have to use the absolute value symbols. Okay, so on this we have, if it's just this right here, it's square root. If it's square root, then it's understood to be 2. So we are looking for 2 of a kind. And how many 2 of a kinds happens whenever we have x to the 4th. X to the 4th means x times x times x, right? So I have 2 of a kind here, and I have 2 of a kind here. Well, how many 2 of a kind of the x's do I have? 2. Since this is even, then my answer is going to be just that, and I don't have to do anything special to it. So on this, well, let me back up real quick. So for this answer, what I could have done is take that 4, put it over that 2, that 4 and that 2, and what's 4 over 2? 2, because you're taking groups of 2 whenever you're dividing by 2. So it's answer's 2, so the answer's 2 there, so we don't have to worry about absolute values. So if I use the same system on this one, that red 2 is that red 2 over 2, because that's a 2 there. So what's 2 over 2? 1. And since 1 is odd, we're going to put that in absolute value. Since it is 1, we don't have to have the we don't have to have the 1, but we do have to have the absolute value symbol. Okay, so I'm just going to keep on going. I'm going to get thinner black. So we have x to the 12 over 2. 12 over 2 is 6. 6 is even, so we're finished. X to the 18 over 3. 18 over 3 is 6. 6 is even, so we're finished. Now this part is when I have to take it step by step. I can't show you the calculator on the computer anymore until I get it fixed. So, but you know how to put the square root of 144 in a calculator, and that's all you would be doing. Square root of 144 is 12. And x to the 14 over 2, because that's 2. 12. 14 over 2 is 7. 7 is odd, so that odd part is going to go in absolute value symbols. Okay, I'm going to grab my calculator. Square root of 576 is 24. So 24 x to the 12 over 2. 12 over 2 is 6. 6 is even, which means if we have an even amount of positives, we get positive, and if we have an even amount of negatives, we'd get a positive, so it really wouldn't matter. It only matters if we have an odd amount of negatives and positives. Okay, so now x to the 5 over 3. Well, 5 over 3 is 1 and 2/3, right? So I'm going to try to do this. We'll put the 2 right there and the 3, and we'll keep the 1 black, and I'll show you where all of those numbers go. The whole number, the 1, is what gets to go outside the radical. So there's a 1 right there. Then we're going to do square root. The 3 is the root, so we have to keep that there. And the 2 is the exponent that was left over because we didn't have a complete other group of 3. So that's what it would be. And then you look at what's on the outside. Do we have any exponents that are odd? Yes. So those exponents that are odd are going to go inside absolute value symbols. And since, oops, just a second. Since that exponent was 1, you do not have to put it, or you can put it. It doesn't really matter on that. Okay, x to the 15 over 2, x to the 7 and 1/2, x to the 7 goes on the outside, the 2 would go here, but since it is 2, you don't put it. The 1 is right here, but since the exponent is 1, you don't have to put it. But the 7 is odd, so we're going to put it in absolute values. Square root of 243, 9 square root of 3, 8 over 2, 8 over 2 is 4, so that is going to come to the outside front, and the square root of 3 is going to stay inside. 4 is even, so it does not have to have an absolute value. This is odd. That one is odd. This one is odd. Whenever it's odd, you don't have to worry about absolute values on the answers. You only have to worry about absolute values as if your root is even. So, negative x 9 over 3. 9 over 3 is 3. So it would be negative x to the 3rd. Negative x to the 5 over 5. 5 over 5 is 1. So your answer is negative x. 5 fifth root of 1024 is 4. X to the 5 over 5, it's 1. Since this is odd, I don't care that my answer is 1. You don't have to have absolute value. Okay, 5th root of 729. Uh-oh. Okay, I'm going to come back to that because I'm going to need more space for it. Let me try one more thing. wrong. 729 to the 1. Nope. Yeah, okay. I'm going to come back to that in just a second. I'm going to need more space, and I don't want to run out of space. I'm going to need all this underneath here. So let me do the easier ones first, and then we'll get to this one. This x minus 2, I don't know what x minus 2 is, but it's just going to stay x minus 2. We're going to put the 18 on top, and we're going to put the 2 on bottom. And what is 18 minus, or 18 divided by 2? 9. Since this is even, and this is odd, it goes inside absolute values, and that's what your answer is going to be. X plus 3 stays in parentheses. 6 over 2. 6 over 2 is 3. 3 is odd. 2 is even, so it goes in absolute value. See, I need even more room for these. I write too big. Okay, so I'm going to scooch this one down here. X plus 4, 7 over 2. 7 over 2 is 3 1/2. So x plus 4 to the 3 is odd. X plus 4 stays inside also. So 3 of them come to the outside, but 1 of them stays on the inside. 7x minus 9, 10 over 4 reduces to 2 2/4. Now, in every other situation in math, I would say reduce that. But since we're looking for groups of 4 and we have 2 left over, we're not going to reduce it because we're going to use that top 2 in just a second. So 7x minus 4 squared goes to the outside. The 4th root stays. 7x minus, oh, that's a 9, isn't it? Where did I get the 4? And 2 is still there. Since this 2 is 2, we don't have to worry about it. Alright, now 729. This is when you're going to start loving me. Okay, 729. Let's see. 729 divided by 3 is 243. Three's finished. 243 divided by 3 is 81. 81 goes to 99. 99 is not finished. Goes to 3 and 3. Both 3's are finished. Both 3's are finished. So how many 3's do I have circled? 1, 2, 3, 4, 5, and 6, right? What is our root right here? 5. So I need 5 of a kind. Well, I had 6 of a kind. So these 5, this one group of 5 is going to go to the outside and become negative 3. Gone, 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 gone. This 3, 5th root, we'll always keep a root, stays on the inside because it didn't have a group of 5 to go with. Excuse me. And then we have x to the 10 over 5, which is 2, which makes x squared, with no x's left to go to stay on the inside. So that would be your answer.